Okay, final video, just kind of um, put the last concepts kind of smushed together, varied from chapters 13 through 15. And then chapter 16 we'll just review with, the other review sheets that other teachers have been making. We look at those. So, all right, let's get it going. So, if you remember chapter, I don't know which one it was, 13, 14, I think it was 13. We started introducing that I number. And again, at least my students remember this is an I do, you do. I'm going to do all the left, you do the right column. And every question is synonymous with the one that I do. So that's all you have to do when you go home. You have an example on the left. If you write during the video and actually watch it, right, then you'll know how to do the one on the left, and hopefully that gets it to sink in, but we'll see what happens. All right, so the whole idea of what is I is equal to the square root of -1. Again, I'm going to go fast because it's a video. You can stop and replay if you want. Okay, that's what it is. It was done way back in the day so that we can deal with square roots of negatives. So we could do this question as a, well, actually this question, number 2 there. Instead of saying no real solution because you can't take the square root of a negative because a number doesn't equal, 2 times 2 equals 4. So that doesn't work. 2 is not an answer. And -2 times -2 equals 4. So that's not an answer. So there is no answer for this unless we break out that I and then deal with the leftovers. So somebody made I equal to the square root of -1. And then what we did in our class is we just stopped at I squared. So what does that mean I squared is? I squared is the square root of -1 times the square root of -1. I don't know why I wrote a 7. Made a mistake. That is equal to -1. So there's a difference between the square root of -1 and -1. Just like I asked my students, would you rather have $4 or the square root of $4? Well, the square root of $4 is only $2. So there's a difference between the square root of something and just that thing. I don't know what else to say about that. So what my students did then was they changed this to I to the 12th times I in their head. All right, because that's true, real basic exponent rules. Let me just make sure we're, yeah. Okay, so then they took I to the 12th and changed it to I squared raised to the 6th. So again, just real basic exponent rules. Then this is all they had to have memorized. I squared is -1. And then all they had to know is what's a -1 raised to the 6th? Well, that's 1. So this is 1I. That's what this reduces or simplifies to. So that's how you go about doing i's raised to a power. All right, we're going to move on because this is review again. So this is stuff that should just be familiar. So how do I do this one? Well, what I say in my class is violence, take out an I. Get that separated from the 16. So split up -16 underneath the radical, the square root of -1 times the square root of 16. What's the square root of -1, everybody? That made up I symbol. What's the square root of 4? Or 16, I'm sorry, 4. So that's what it is. It's 4I and you're done. Okay, and then that's just a hiding square root of -1 isolated so we can deal with that. Should have came up with a better example on this because look at the previous one. But anywho, don't just be like a robot. Oh, we're doing I now, so everything's I. No, square root of 25 is 5. These negatives do not cancel. Inside, outside of jail. Square root of -16 you just learned from the last question is square root of 16, 4. Square root of a negative, I. 4I. And then this is the answer. Let's move on. I do, you do. You got one on the right. Now this says plus in between, so you're going to add these. I could take 12 plus -15. This is not useful parentheses. These are meaningless. This is not a FOIL. I don't know why they do that sometimes, but it just, so the student knows the difference between multiplying two binomials and just adding like terms. These are non-I numbers, so those just add. But what we need to do is bust or break these down. So what's the square root of -20? I'm going to lasso that. I guess I won't. Rewrite that down here. So this is -3. Done with these. But then what I have to do is simplify these. I'm going to do it fast. 20. I'm sorry. Square root of -20. Square root of -1. What's that? I. And then 20 is 4 times 5. So square root of 4 times the square root of 5. So this ends up being 2I root 5. I guess I'm getting a little messy with how I added these like terms. So let me put the negative 3 here plus this 2I root 5. And then this one is square root of negative 1. And then this is 25 times 5. Square root of 25 is 5. Square root of negative 1 is I. 5I stuck in jail, root 5. And then lo and behold, these happen to be like terms. My students did recognize that back in the day without me really having to say anything about that, so they were good with that. All right? So this one represented a simplify the I numbers and then get like terms together. Yet again, this says plus in between. So these parentheses are meaningless. This is not a FOIL multiply. I mean, look at 2 down from here. The difference between that and this one. Right? That is a FOIL because there is no plus in between. If this said minus, then you distribute a negative. All right? All those things. Like terms. 4. And then I works like X. When you have an I number plus an I number, you just add the coefficients in front and you're done. Okay? All right. So just treat I like a variable sometimes on questions like this. This is sort of like a variable question, but then I is special. 2 times negative 1 is negative 2. I times I is I squared. If these were x's, you'd be done and you'd circle this. But I just wrote this up above. I is the square root of negative 1. I squared is a free negative 1. Big difference. So what does this become? Negative 2 times negative 1. And that is 2. Okay? So something similar is going to happen on the next two. If these were x's, you'd be fine. You'd distribute. And then you'd say 11x. Hope I'm not confusing people by saying that, but then 12x squared. But it's not. These are i's. This stays, because this is just 11 times the square root of negative 1, stuck in jail. So that's done. But then this, everyone knows that got good with this, turns into 12 times a free negative 1. So minus 12. Now, I don't know if your teacher's real sticklers with making sure you put it in A plus BI form or else you're doomed. So that would be the A plus BI format for that. Okay? All right. So I'm just going to move on. Okay, this is well, let's just say distribute, in case I'm using an illegal word. So distribute this negative 7 times 1. Do the lines. We distributed on a previous video. The only difference is we're dealing with i's now instead of x's. Then you take the 11i and multiply it by 1. And then the 11i times 2i, which is 22. And then I times I is I squared. I have a ton of students in my class just ignore the I times I part. All right? These are just variables. These are the square root of negative 1, square root of negative 1 stuck in jail. So these are just like terms that can be added. So this is minus 3i. Whereas this turns into a free negative 1. And then this is negative 1 times 22, which is negative 22. Now it's real. Now it's getting real, man. So I can go ahead and add that to the negative 7 and then put it in A plus BI form or else. Okay, so flowing right along. These were those annoying questions. So what do I have to do to get this I out of the denominator? Actually, this is called rationalizing the denominator because this is the square root of negative 1 down in the bottom. Used to be a concept really taught how to do. We didn't hit it this year too much. Maybe as an add-on, but what we have to do is multiply by the, what is negative 4 minus 3i called? Correct if you said conjugate. Good. So know that this is called the conjugate of that. All right, so this is what I would multiply both top and bottom of this fraction by to get the I out of the denominator. This is equal to 1. That's why it works. Something over itself. So that's why I do both top and bottom, because I want to multiply this fraction by 1 and not change its value. So this is what we would multiply by. Go ahead and distribute the top, negative 44i, and then here we go again. negative 33, 11 times negative 3, and then I times I, which is I squared. Well, this is just going to be turn into 33 when you're done, because I squared is negative 1. Let's get the bottom. Now, the purpose of the conjugate is the middle term is going to be destroyed. So this is 12i, and then this is negative 12i. So I have no more i's on the bottom, because the last distribution is negative 9i squared, which this turns into, so cancel these. It's the whole point of the conjugate. And then go ahead and simplify your I numbers. I'm just going to do this right now. This is negative 1 times negative 9, so this is 9. So the bottom is 16 plus 9, which is 25. The top is that negative 44i, which stays, but then this turns into negative 1. Negative 1 times negative 33 is plus 33. Now, you should write this maybe in a plus bi form, so you should write the 33 over 25 first. And these don't reduce. Minus or plus a negative, be able to handle that, over 25. This is how we wrote our answers quite a bit. You could also write it as 33 minus 4i all over 25. I just kind of reversed these two to make it a plus bi, at least looking like. All right.